Thank you for watching this video. This is day 3 of Unit 5. Simplify. I would like to have you guys start off by deciding what is the difference between simplifying and evaluating and solving. So there are different rules that apply. So let me give you a problem like 4 to the x equals 8 to the x minus 5. And then, so that's an equation where you have to solve and find what x is. And then there's simplify, where it's just, you've got powers like x to the 5th, y to the 1/2, to the 1/5. I don't know, something. Let's put a number in there. 32. There we go. Okay, I want to know what are the rules. I'm not worried so much about what the answers are. I want to know what things can I do in this situation, and what kind of things can I do in this situation? Because there are special things that we can do somewhere that we can't do somewhere else. So think about it with your groups, talk about it, and then we'll check in. Okay, so my question is, what can we do here? What's one operation, one strategy we can use on this guy? Strategy. Yeah, Hannah. You can distribute your exponents. So you're using a rule of exponents, right? Laws of exponents. Cool. What else can we do? What can we do to the 32? Should we just leave it 32, or could we rewrite it? And how could we rewrite it? Yeah, no? So we could say the 5th root of 32, so we could change our rational exponent, let me say this right, rational exponent can get changed. You guys all know delta, changed. That means changed to a radical. So really what we're doing here is changing forms. Right, so we could say, what's the 5th root of 32? That changes the form. Okay. What else could we do to 32? We could do something else to 32. Does anybody know 32? Is 32 a special number? I think it was on that list of special numbers that we wrote down the other day. It is 2 to the 5th. So we could take a number and we can rewrite it as a base with a power. So we can basically replace something with something that's equal, right? So I can take something out, replace it with something equal. How do you write that? Any suggestions? Replace with an equivalent number? I don't know. Replace a number. Replace a number with an equivalent. Is it valent or villain? Oh man, equivalent. I'm gonna go like that. And if I spelled it wrong, I apologize. Equivalent. Anyways, with an equivalent number. For example, 32 is equal to 2 to the 5th. So we can take something out, replace it with something that's equal. What else can, like, if it's just, I don't think I'm going to be able to fish this out of you guys, so I'm just going to suggest it. I can always multiply by a form of 1. If you ever want to change something, I don't think it really applies to this problem, but you can always make something multiply by 1. Multiplying by 1 is not going to hurt anything. It's not going to change the equality. Multiply by a form of 1. So that could be like 6 over 6 to get the same denominator or whatever it is. So these are some great strategies that you can use when you're simplifying and evaluating. Now, what changes or what's new? I think all of these apply for solving. You could do all of those same things, but what now is unique about solving that we couldn't do over there? What's the new thing? Okay, now we can get x on one side, right? So now we have this concept of sides, right? So I have this left side and the right side and the left side. So I can get everything on one side. Okay, so we want our goal now has changed, and that is, our goal is to isolate x. Okay, we don't need a comma there, sorry. What else? If we have sides, what can we do? Yeah, Jennifer? Great. So this is similar to which one here? Replacing a number with an equivalent number. So we can take out the 4 and replace it with 2 squared. We can take out 8 and replace it with 2 cubed. So that will help us, definitely. But what makes solving unique? What makes this, what can I do if I have an equal sign? Right? I like to think of this as a balanced there's a little fulcrum, right? And this is balanced right now. There's a teeter-totter, but it's balanced. And I need to keep it balanced. Yeah, well. Yeah, definitely. Finding x, that is our goal. We want to find what x is, right? But what am I allowed to do? Can I say, oh, let me go times 2. I'm just going to double that side. I think that would help. I'm just going to double that side. Is that okay? I can just double this side times 2. Is that okay? Am I going to stay balanced? No. So what is the rule when we have an equation? What's our rule? Nira, what do you think? Same thing on both sides. All right. Now do the same thing on both sides. So whether I'm adding 2 or subtracting 2, we can do the same thing on both sides to help simplify. So do the same thing on both sides. That will help us maintain our equality. All right. Cool. We good? All right. Now, if over here you told me, oh yeah, just do the same thing to both sides, would that make any sense? No, we don't have an equal sign. We don't have 2 sides that we can do the same thing to. So it doesn't really make sense here, but that over there it does. So that's just a quick overview of how solving is a little bit different than evaluating or simplifying. Here we can multiply by 1, change forms. There we can multiply by 1 and we can change forms. We can do all this stuff, but we also can do the same thing to both sides, and our goal has changed. We want to get x by itself. Okay? Cool. Thanks for that quick check-in. All right, tonight's homework is a worksheet. It's worksheet number 2, and I have it over here. It's a whole 13 problems, but some of them are really quick. We'll look at some strategies for solving them today. We were going to have a warm-up quiz, but we just changed that, so whew, deep breath. The warm-up quiz was basically on day 1, simplifying stuff, so I think we're going to do that tomorrow, and it's going to be a graded group activity kind of thing. We'll do some solving examples in practice and maybe a little more graphing if we have some time. All right, so you guys did not get this worksheet because I didn't put it out. So let me give you this worksheet. All right, so we have 3 different examples we're going to go over. Katya, I think that you need to go now. All right, so example number 1, we are solving, we're finding what x equals. We have 2 sides, so we can do what? What does your gut tell you to do? Want to get everything else away from x. What would you do first? Yeah, definitely. Minus 5, x to the 3/4 power equals, take 5 away, and that's what? 729? All right, now 729, that's an important number. I'm pretty sure it's a power, something to some power. So I see some people grabbing their calculators, which is good. We want to break down and figure out, okay, what is that number? What times what? It has a 9 in the end, so it may be a factor of 3, it may be a factor of 9. I want to go 729 divided by 9, yeah. 3 to the 4th. All right, so I can rewrite this as 3 to the 4th. Now, I don't know if I agree with that, because 3 to the 4th is actually 3 times 3, which gives me 9, and 3 times 3, which gives me 9, and 9 times 9 is 81. So I think 3 to the 4th is 81. So double check it. 9 to the third. So you feel like if I break it down, I go 9 times what? And what the other thing that is the what is 81. Yep, that makes sense, right? 9 goes into 72 8 times, and 9 goes into 9 1 time. So 81. And then 81 is 9 times 9. So I can rewrite this 729 as 9 cubed. All right, so I think that would be a good next step is rewrite 9 cubed equals x to the 3/4. All right, now when I have a fraction in my exponent, the way to get rid of it, do you guys recall? How could I make this into a 1? I want that to be x to the 1 power. So I want to raise it to a very special power, and I have to do the same thing on both sides. So I'm going to raise each side to what exponent? Yeah, correct. Sorry, Becca, right? I was going to say Carly. Becca. Raise it to the power of the reciprocal power. Exactly. So 3/4 becomes 4/3. We're going to multiply by 4/3. In our exponents, they're going to multiply, but we're raising it to that power. So if we raise this to the power of 4/3 as well, this cancels with that cancels that, and we get x to the power of 1, which is what we wanted. And then here we have 3/1, so we multiply 12 over 3, or the 3's cancel, and we end up with 9 to the 4th power, which is even bigger than that. So 729 times 9 would be our answer. All right, so do we want to calculate that out and give an actual answer? Can someone help me out? 9 times 9 is 81. 6,000? 6561. So I would say that would be the answer for that one. I would like you guys to try example 2 on your own, real quick. I don't recall getting that as my answer. All right. So earlier somebody suggested, or had a really good suggestion of changing that 4 to 2 squared and changing the 8 to 2 cubed. So that helps us by getting the same base. But it's still to the 3x power. And this is still to the x plus 1 power. So the only thing that we did was we changed the way 4 looked, and we changed the way 8 looked, but it's still the same amount, right? Then what do we need to do? Yeah. Very good. So we want to get our exponents multiplied. So we have 2 to the 6x and 2 to the... Ooh, this is where people make mistakes. What do you guys think it is? 3x plus 3. Good. That 3 is multiplying both parts. It's kind of like that. So 2 to the power of 3x plus 3. All right. So now, we don't want to say the bases cancel out. We don't want to say they cancel out, because they're not really canceling. It's just one of those like logic puzzles. Really, to solve this, you would use a logarithm and change forms to get rid of the base of 2. Or set it, take a log base 2 of both sides. Log base 2 of both sides would make those 2's go away. But we can just use logic. We don't need to use logs. We can just say, well, since the bases are the same, and these two statements are the same, then their exponents must also be the same. But I do not want to see this kind of thing, like, oh, look, they cancel. Like, they don't cancel. It's just logic that we're using. Okay, so 6x must be equal to 3x plus 3. Okay, now we're back to algebra 1. And we're just like, all right, get all the x's on one side, minus 3x, whoop, minus 3x is 3x equals 3, and divide by 3, and x equals 1. Whew. Now, before I say, okay, I'm done, I'm moving on, what would be a good idea? Yeah, what would you do, Hannah? Good idea. Let's plug in the 1 and make sure it works. So 4 to the 3 power, 4 cubed, is equal to 8 to the 2 power, 8 squared. So 4 cubed is 64, and 8 squared is 64, and that is a true statement. So I'm pretty confident that I got that one correct, that x equals 1. Okay, it's really fun, nice when you get to check your work. This also you could plug back in. It's just a larger number. If you had your calculator, it'd be really nice. You want to be careful if you put raise an exponent, you want to make sure to put it in parentheses. So if in your calculator you do 6561, to the power of 3/4. You want to make sure that that exponent is in parentheses, or do the 4th root of that cubed. Or you could just work it from this step and plug it back in. So then you would get 9 to the 3rd power plus 5. It works. All right, cool. 2 examples down, 1 to go. All right, this guy. Whew. What do you guys think? How about I give you a minute, you work with it, and then we'll see if we agree or we disagree. We'll try it on your own, and then we'll check in. All right. I think you guys had some time to get going on this and get started. I saw a lot of people divided by 20 as their first step. All right. So at this point, Katya, you want to go ahead and get caught up. We had, at this point, we've got 1/2 and we got 1/4, and we want to get the same base. Huh. I just realized an easier way to do this. So maybe sometimes dealing with fractions is a little nerve-wracking. Maybe you're like, I don't know, it's kind of scary. How can we make this not a fraction? How could I rewrite 1/2? 1/2 is the same as 2 to what power? How do I make that 2 go down into the denominator? A -1, yeah. So I could rewrite this, instead of a fraction, have it 2 to the -1, and then maybe that'd be easier to deal with. 2 to the -1 to the x over 3. And how would I rewrite that one? 4 to the -1. Okay. Have I lost you yet? So instead of dealing with a fraction, I can deal with 2 and 4. And aren't 2 and 4 a little easier, maybe? 4 is the same as 2 squared. So I can rewrite this as 2 squared to the -1. And then if I multiply those together, I have 2 to the -x over 3. And over here I have 2 to the -2. Alright. 4, I just took 4, like -1's still out here, but just 4 is 2 squared. Right? So 2 to the -x over 3 is equal to 2 to the -2. So we could also do it with fractions and say 1/4 is the same as 1/2 times 1/2. And then we could rewrite that as 1/2 squared. So that would also have worked. I just thought, oh, we can make it so it's not a fraction. Then we would set these equal to each other. I would want to multiply by -3 on both sides. And that would give me 6 equals x. Negative cancels, 3 cancels, and I get my answer. Whew. So we want to double check. Plug it back in. 6 over 3, half, that would be 2. I'm sorry. Wait, 6 divided by 3, yes, is 2. 1/2 squared is 1/4. 20 divided by 4 is 5. So it works out. Awesome. All right, so hopefully you got enough strategy today to get all of those 10 done. So on the back, there are 10 problems. Let me get to the page. Oh, there we go. On the back, there was one error. This shouldn't be 2/3, it should be 3/2. So these are 10 problems you have to work on. You got about 15, 20 minutes to work on them? 15 minutes. All right, so go ahead and get working. I'm going to number them just so that we can talk about them easier. 1, 2. Yeah. Do you have a question? No. 5, 6, 7, 8, 9, 10. All right, awesome. So work on those in your groups and we'll check in with the answers. All right, if you're seeing the answers now, you want to maybe go back, pause it, write them down, try these problems, and then check your work. But these are the answers that I came up with. Yeah, so thank you for watching the video, getting caught up. Please spend some time trying these problems and making sure you understand them. There's going to be a quick quiz, graded group activity on Friday, and then a quiz coming up not too far in the future. So you want to make sure you're practicing. Okay, thanks for watching.